Right. So in this video, we'll see what are the data types in data science and how to handle them. We have got four types of data in data science. That is nominal, ordinal, discrete, and continuous. Now, basically, the nominal and ordinal, these are the numerical data that are in numbers and that you can measure. So that is not the scope of this video. That will be in separate video. Here in this video, we will be discussing about the categorical data, because categorical data is something that we need to encode and we need to transform it before we can feed it to the model. Because in machine learning, the model is something that do not accept the string data or the categorical data. So we are going to encode it, we are going to transform it for the machine to be able to understand. So for the categorical data, we have got two kinds of data, that is nominal data and then ordinal data. Okay, before we go to the coding part, we'll try to understand the meaning of the nominal data. So what is this nominal data? Something that is related to nomenclature, something that is related to naming, like the marital status. It could be single, widowed, married, or like the hair color, or like the age, whether what is the age. Age is a number, but you are able to describe some of the properties, some of the properties of a person using the age. So variables that is without any order. Okay, and you cannot quantify it and you cannot describe it. You can only, sorry, you can only describe it, but you cannot quantify it. It is not measurable. That is nominal data. So what is ordinal data? That is the next. We have two kinds of categorical data, nominal and ordinal. Nominal we discussed, and ordinal is something related to order, whereas nominal is not related to order. It is related to order, the observational data, like anything that you scale on. Like what is the happiness, how do you scale yourself, what is your education level, whether it is primary, secondary, or higher, what is the economic status, like you have a strategical hierarchy of economical status. So that is strategical hierarchical data, and it is observational data. And that is known as the ordinal data. How do you handle the nominal data? So as we know, the nominal data is something that observational data and that has some order. So we will be using three in machine learning. We have a lot of methods. You can also apply uh, manual encoding. But when you have a lot of features in that, you would need some kind of modules to, to do your work rather than suppose there is some we will see that in coding section there is some 3 to 4 categories of data. When you value count that, you get 3 to 4 categories of data in a particular in a particular column. So in that case, doing the manual thing, like doing 5 encodings, and then the model will feed feed the model the 5 kind of things, and it will process it. So it will lead to the discrepancy in prediction. The model will not be able to predict it properly. So better you need to use this three modules, that is one hot encoding and get dummies and label encoding. This get dummies is from pandas, and scale learning pre-processing you will get one hot encoding and label encoding. Are the modules that will transform your categorical data into binary data. Now, binary data in the sense 0101. Suppose in case of one hot encoding, will convert that into binary form so that the machine will understand if it is 0, then what properties it is. If it is 1, then what property it is. So it will be more clear when we go to the coding section. For now, you just understand that we have got three main libraries that every data scientist tend to use this data for encoding the data. To handle the ordinal data. So we have discussed ordinal data is something which is not related to order and which is uh, basically something that you can describe and you cannot measure. So visualization tools like Seaborn and Matplotlib, these are the tools with which you can do the measurement of the ordinal data when we are doing the when we are doing the measurements and we are doing the data type conversions. We will study more about how to handle this data in sometime later in coding section. But here, just understand we can visualize this tool. We can use this tools to visualize, and we can encode ordinal data. That is, the process is known as ordinal encoding. That is also one kind of way to convert the categorical data to the numerical data to be able to fit to the model. So basically, suppose you see economic status, you have high, low, and standard economic status. So how do you ordinal encode it? So you have to create a dictionary. In Python, there is a method for there is a way you could create a dictionary, and you put the key as this economical status like high, low, standard, and values like 0, 1, 2. That is hierarchical value. 0, 1, 2. So anytime the model will see high, it will depict as 0. Anytime the model will see low, it will depict as 1. And anytime the model will see standard, it will depict as 2. That is one way. That is manual way you can do that. You can import it yourself and then you can put the data when we're feeding it to the model and then it will do the work. Now another one is like we have a library that is sklearn. So in sklearn pre-processing sub-library, you have an ordinal encoder data. Ordinal encoder module. You can use this module to handle ordinal data to convert it to the binary form. It will give you some of the numbers based on the based on the type of the ordinal data you are trying to handle. Okay, so now here we have got into the coding part, and we will understand this concepts that we discussed using the coding. Now I have got a data set from Kaggle. That is Kaggle. This is the site where you'll be getting all the data sets. So this is the data set of a passenger passenger trains and whatever passenger are traveling in the train and what are the things, what are the features been allotted to them. So this is like a data set which contains all the information. So first of all, when we have a data set, we need to study it. Like what is the data set and what are the types of the data set? Datas are in it, and what are the data types? How many features are there? What are the number of categories of the data are there? So first thing what we'll do is we'll just load the data. We'll use pandas. First of all, anytime you do the data analysis, you'll have to import panda in NumPy. Now, the next thing what we need to do is we need to read the CSV file, and that is PDCSV, and uh, you have to see if there is any kind of null values or not. So I have got a like null age we have 177 null values and cabin we have 687 null. Handling null values is a different topic that we are not discussing in this scope. We will have videos to discuss that in future. But these are the data which have null values. Now we can also get the data that is the entire data. We can log it, and then also if it is a large data set, we can use head function to log only the particular 5 data sets, or we can use tail. This will get the data. Head will get the data from the initial part, and tail will get the data from the final part. So first we have got this like 890 890. So if I do the shape, so if I do the shape if I do the shape we are getting 890 uh, rows and 12 columns. So here also, if I confirm it, I have got this 12 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 columns and then 890 rows. So that's how you take, you see what are the data you are getting. So here also you can see what are the rows and the columns. Now the next thing is that we have to see which are the object types. Like first of all, I can do what are the data types. I'll do this data types. So here, these are all the columns and these are the data types. We have int, object, float. So for this categorical transformation, we have to understand what are the object data types. So these embarked, cabin, and all of these are object data types. We need to handle that. When we get all, the first step is to get what are the categorical data types, and after you are getting what are the categorical data types, you have to find out which one is the ordinal and the nominal. So here, obviously the embarked. So if you look at this data, embarked has got SC, SS, SC, and then SQ. Now, so this is also one of the way to find out what are the categorical data. So name, sex, ticket, and cabin and embark, these are the categorical data. Now, I want to understand which one is the normal categorical data. So I'll take this embarked uh, column and I'll find out what are the features in it, like what are the type of the categories in it. So how to do that? So what, in order to get the categories, I'll do the value count of the column. So this is my data, sorry, data and embark, we get the column. You can find out this will get the column. And if you are doing the value count, that is one of the function provided by uh, Python, count, sorry, Python, you will get SCQ. So basically, you are getting the SCQ. This is the way. This is the way you see what are the types of the counts of the, what are the categories of the categories inside the particular data type is there. So for how many data types for name, if you see, we are getting this much of data types. These are all 111. That means these are all distinct data types. We need to do feature engineering for that, so that we will have some, like we'll find identification of these data types, and then we'll have to concat it and then split it and then put it in a separate column. That is a different scope. It's not in the scope. We will be doing this later. But that's how you do the feature engineering if your value count is like very unique or 111. Now, for ticket, if you want to see the count, you can see. So we have got this kind of tickets over there. So we will understand how we can handle all of this categorical data. So, so first we'll focus on embark data. So any kind of column that will give you 3 or 4 or up to 5 categories of data, you want to you want to understand that this is the nominal data. I mean, this is the data that is not in order, and you can apply uh, nominal encoding to the data. So as we discussed in our theoretical session, that we need to create a dictionary. This is how I create. I'm doing it for mail. You can do it for embarked also. Suppose I'll just create a new column and create a dictionary, and I'll just pick up this F as 1, P as 2, Q 3. So this is how I'm encoding. These are the 3 features and I have encoded it to 1, 2, 3. Now the next thing is that I'll create another column that is encoded dictionary, sorry, encoded embarked. So what I'll do is I'll iterate the column, the original column. I'll iterate the original column and then I'll put a map function and I'll run this dictionary to all the elements of the map function. So this is how I'll get the entire column, I'll map, I'll put the dictionary function, dictionary to all the elements of the function, all the elements of the columns, and then store it in a different column. So if I will log this column, I'll get this kind of encoding. See, here, like if I will take another cell and if I will do data dot head, so I will get this. So here you see embarked column is there. S is stands for 1 as we did it. S it stands for 1, so we are getting 1 over here. C is 2, so we are getting C over here. If we go to the tail, let's see if we can find Q. Yes, so Q is there, it is encoded as 3. So that's how you do the usual encoding. That's how you do the manual encoding. Okay, so that is for nominal data. Now, how do you handle the ordinal data? So I have also done the same for the sex column. So you could do this also. Even nominal data, you could also use another way that is known as we go for the ordinal data. So what is, let's just revive what is ordinal data. So something that is measurable like happiness and whether it is a dog or cat, and then whether something that is you can measure in at a scale of 1 to 3, but you cannot measure. That is the category. So what are the ordinal data over here? Even embarked is also ordinal data. We have got 3 categories. Anytime you have got 2 to more categories, you can either use it as you can either encode it as like ordinal data, or you can encode it as like uh, nominal data. So here we can use both the things, but what we will do is I'll just go see what are the other data types we have, and I want to show you some other ways. So we have got sex, we have got ticket, fare, cabin. Let's see what are the value counts of cabin and whether we can encode it or not. So these are the, like we have got 4 B 96 and 94 6G4 counts are there, one. So this is mostly like a lot of features are there. So you do one hot encoding for a lot of features. For the columns that have lot of features. So what I'll do is here I'll just import the one hot encoder and I'll just remove this parse uh, because we have got the warning in it. So this is how you declare one instance of the one hot encoder, handle and non-ignore, that you can find it in internet. That is the basic way of create the instance of one hot encoder, and then you will use PD data frame to fit the encoder. So I'll just run it. Okay, so it's not defined. So I have not run this. Okay, let me just run this, and we store this instance in this variable, and then I run this. So you are getting this. So it is one type of encoding. This feature needs a lot of feature engineering. feature engineering, like we have to do some kind of feature engineering to this. Like how do we handle this? We have to find some pattern in this, like we have B categories over here, then we have G categories, and then we have C categories, and we have to see what are the B categories, because cabins are distinguished as A, B, C. So we have to do the classification based on that. So we have to do a feature engineering. That's why this kind of data is coming. So if we go back and see what else we can do. So what I have done previously is, yeah. So I have done this feature engineering. I have used the name like this is the name, and I have used the Mr. Mrs. String portion of the name to understand whether they are married or not. So after they are married, after I did this feature engineering, I got this value. Okay, I have to run this. I got this value. So these are the features, like we have got Mr. and then Mrs. Now if I do a value count, let's see what happens if we do the value count. So we are getting this M status. Am I not storing it somewhere? Okay, Mr. and Mrs. and then. Okay, depending upon the, like we do the value counts, I did the value counts, and then we could see there are a lot of values. So we kind of can do hard coding to that, but we will handle that in a different manner. Label encoder will use. We can do that, but now I want to show you the, like here, if I will do this transformation, I'll just coming back to hot encoders, I'll just do the cabin hot encoding. So we'll create one hot encoder substance, and then we'll have to use the fit transform function, and then uh, put the arrays in that. So here we can you can give multiple columns and then converting it to array. So here I'm able to see these are the encoded values. These are the hot encoded values. Okay, so you are getting 890 rows and then 148 columns. So now, if I want to see, like these are the encoded values. We are getting one, and we are getting zero. So the cabin values are being converted to zero or ones. Now, if I want to see how this looks in case of the data main table, so I'll just do a join to this one to the data table, and then I'll run it. Okay. It is join. No. Okay, that didn't work. So the thing is that key, we can see the encoding part over here. If we want to join, we'll just have to log the data. So here we can see, like if I do the head, will not let me not to just print it all. So here you can see that we are getting all this encoded data over here. So that's how you do one hot encode. You could also do it for multiple columns, but that's how you do the one hot encode. Now the next is get dummies. As we saw, the first one is a one hot encoding, then get dummies, and the next one is the label encoding. So we have got two more encodings to be done. Now get dummies encoding, I'm also doing it for cabin because I've got three parameters over there. So if I will run this one, I'll get like these kind of columns that has been created, and whichever column is true, it will show true. Whichever column is false, it will show false for the particular row. So these 308 columns is added based on the true false value. So that's how you do the get dummy. Now Next comes to the label encoder. That marriage status that we saw, we did the feature engineering and all of these things. Now I will put that in the label encoder. I'll do the label encoder and I'll fit transfer the same thing that you did in the one hot encoding, and I'll do the class, and here I'll get an array with all the encoded values. You see a lot of 17s over there, lot of 18s over there. So the 17s are the Mr. and Mrs. And it is actually what this label encoding is doing it. It is actually taking the mean of this, like whatever it will be doing the frequency distribution. Like here we are getting a lot of Mr. and lot of Miss and lot of Mrs. So what we'll do, if anything that is like this unique, the first thing is that anything that is very much unique, you can ignore it, or you can replace it with using the uh, anything that is like not so is very unique. We can ignore it. So here we can put a zero value to this one for the model to understand, and we can only take this Mr., Mrs. and master value, and then the same thing is doing with this. So it is encoding like 14, 18, 17, and somewhere there is 22. So here how many count values are there? 1, 2, 3, 4. So here also 1, 2, 3, 4. So there are 4 kind of encoding. So it is also doing the same encoding. Whatever values are very unique, it is just leaving it, and it is taking the majority of the value counts and then putting it and encoding it accordingly. So that's how you do the label encoding. So in this video, let me just summarize. We did nominal encoding, that is uh, without order encoding, and we are using manual encoding for that. And for ordinal encoding, that is orderly encoding, we are using 3 kind of methods to that. One is label encoding, one hot encoding, and then get them. So these are the 3 or 4 ways you can input the categorical data and feed it to the model so that the model will be able to predict it correctly. So if you would like this video, that's it for this video. So if you would like this video, just like, share, and comment in the section so that I'll get to know what are the things that you could not understand. I could make some efforts from my side to make you understand. Thank you.